Akanksha. Akanksha is a senior engineer at Adobe. She's worked on multiple distributed systems at Adobe. She's worked on many data pipelines for ingestion with Spark and Flink. And she's also spent quite a bit of time looking at FoundationDB, specifically around how we can use the customer managed key features in FoundationDB. And today she's going to talk about this Spark connector, Apache Spark connector that we built for FoundationDB and how that is designed. So take it away, Akanksha.
Works. All right, before we begin the talk, I just want to get a sense of how many here have maybe worked before with Apache Spark or FoundationDB in your prior work experience, and maybe both. That's cool. All right, a little bit about me before we begin the talk. So I'm a senior software engineer at Adobe. It's been 8 years I'm working with Adobe with different teams. Currently, I'm working in Adobe Experience Platform, Identity Graph team. We handle stitching identity graphs across distributed systems, and we build across large data sets. I specialize in big data technologies like Apache Spark, Flink, FoundationDB, and Data Lake. Outside of work, I love running, and I've run a couple of half marathons. All right, I think before we talk about it, I think let's just get a sense of why we need a Spark connector for FoundationDB. So in Identity Graph in AEP, we process billions of events, around 30 billion plus, including both batch as well as streaming modes. So to handle that big of a processing, we need some robust solution for both storage as well as computation. For computation, we leverage Apache Spark, which excels at handling large data sets and is also a powerful distributed processing engine. For storage, we rely on FoundationDB. It provides strong consistency, transaction guarantees, as well as scalability. So the connector enables bulk read and write operations. And to maximize the use of these two technologies, we need a way to connect from Spark to FoundationDB. That's where this Apache Spark connector comes into role. It also enables us running ETL analytical workloads. All right, so before we deep dive into how this connector is built and the architecture around it, let's go and understand some of the key concepts in FoundationDB, starting with data model. So FoundationDB is ordered key value stored. Keys are unique, stored in a lexicographically based on the byte values. Okay. So there's also a concept in FoundationDB called subspaces. Think of subspaces like a logical partitioning, which groups your keys together based on the related keys. They're defined using prefixes. A prefix is essentially an identifier that you prepend to every key when you're defining or adding that. This also helps avoiding key collisions. So for example, if you look here, we have a global key space, and within this key space, we have alpha, beta, and gamma subspaces. Here, the key is user1, which can coexist in, even though it's the same key, but because we are identifying it with a prefix, it can help avoid those key collisions. All right, so now let's talk about range queries. So in FoundationDB, one of the most powerful features is range queries. It allows us retrieving a contiguous set of key value pairs within a specified key range. So as we learned in the slide before, keys are stored in lexicographical order based on their byte values. So when we are retrieving these values from a specific key range, we are going to fetch the related keys together and in a contiguous key block. So this makes the retrieval very efficient and also minimizes the disk access because we are retrieving the adjacent blocks and keys altogether. All right, so here is a neat FoundationDB API that is provided by the client to get range. Here we the client will pass in start key, end key, limit how much data you want to retrieve, do you want it in reverse order or non-reverse order, and streaming mode. In the next slide, we'll see what each of these means. All right, so starting with batching. So range queries, as we learned, is a powerful feature. But let's say client comes in and asks for a substantially large key range. Then how do we handle it? For doing that, batching helps us split large range queries into smaller chunks. So in the prior slide, we learned about the limit. So this is what we're talking about. The FoundationDB client allows us providing a limit, which is the max number of records we want to fetch in the batch mode. If the number of key value pairs are more than the provided limit, then it'll only fetch based on that limit, and the client will have to do the batching or pagination to retrieve more keys. So let's take a look here. Let's say I have 8 keys, and I'm providing the limit as 3. So in the first batch, I'm only able to get K1 to K3. Then it's going to skip K3 and scan the next 3, and so on. That's how the typical batching pagination works. All right, so on the client side, let's say I do provide this limit, and I come up with a scenario where I can't really access all the keys in one go. So how will that flow look like? So I'll fetch initial batch based on the start key and end key, and also I provide the limit here. So the first thing we're going to check, does this batch have more items that need to be fetched? We can check that based on the batch key index. If it does, then we are going to process the current items that we retrieved. And the second thing is we are going to set the new begin key using a key selector API that are provided by FoundationDB, which is going to skip the last key it read and starts with the first key greater than the previous key. That way, we'll fetch the next batch from storage, and we'll continue repeating this step until there are no more items to be read. So this batching helps in partitioning the data into smaller chunks, and that's how we're able to do optimal reads. All right, so another key concept in FoundationDB is streaming mode. So when we learned about limits and batching, there is another neat API that FoundationDB provides, which is streaming mode. It allows clients to how data is fetched from the database. So basically, the API helps in splitting the data again into chunks, and there are different modes available. What it helps us with is managing the latency, how quickly the data is retrieved from the database, and also bandwidth. That, I think, goes with any typical batch operation because we can control how much data we are reading. So it will also help with the amount of data transferred over network. And the choice of streaming mode really depends on the use case, and we need to figure out how we want to choose this mode. So at Adobe, in this Spark connector, we are using streaming mode want all. What it does, it fetches the entire range of the key as soon as possible, right? But having said that, your use case, you have to decide what mode to use. You may not have to use want all because the typical, it depends on the expected data size and also the data processing. All right. Now let's talk about one of the very cool features of FoundationDB, which is locality info. So locality info is a utility which helps a client understand what are where the keys are located physically in the cluster. It tells about the network addresses, that is, in which storage servers are responsible for processing which range keys. Right? So given a range start key and end key, it's going to provide me an iterator over the boundary keys, which then I can use to efficiently navigate through these key ranges across the cluster. This is what we'll use as a core piece in Spark connector, and we'll deep dive on how we use this locality. So this is what the database API looks like. We have get boundary keys, we provide database or transaction, and we provide the begin key and end key. All right, so now I think the core part of the connector, I'll come here, so I have the. So let's start with the important components here. We have Spark application, which is the client, which is starting the read or scan on the database. Then we have Spark Driver. Spark Driver is the core piece or the orchestration, and it also helps in managing the task distribution across different workers. The next thing is executors. Executors is a typical worker in a Spark cluster. It does the actual data processing, and in our case, the scanning and doing a range read is what the executor will do. And then finally, the last component is FoundationDB, which is the key value distributed fault-tolerant database. And it is typically distributing data across different storage nodes, as you can see here. So in the flow of events, the first thing is, whenever the client issues a read, Spark Driver is going to go fetch the information or the boundary keys for the range they're asking for. This is what we just saw in the previous slides. So once they have locality info, we'll convert these ranges into what we call as input partitions. So with any data Spark SQL connector, everything is converted to an input partition. These input partitions are then split across the executors. So locality ensures that we are picking the keys which are adjacent to each other, making sure the operation is efficient. Right. So now let's deep dive into one of the first stage, which is partitioning and locality awareness. So since the driver is able to figure out the locality information from FoundationDB, and they pretty much know the physical address of those keys, they can then decide and break down those range keys into boundary keys. And that's what will govern the input partition where I'm scanning the data from. The number of input partitions are determined by the number of key ranges. So you can imagine there's a one-to-one mapping between the key range and Spark input partition. There are two partitioning modes available. One is simple, and another one is locality-based. So let's maybe first start with the simple partitioner. Simple partitioner helps in splitting the key range based on a fixed batch size. So the number of partitions is determined by the size of key value range and the batch size that's provided. Advantages are, it ensures data is partitioned equally amongst these batch sizes. Disadvantages is it does not really account for locality of data. So if data resides in a different storage server, we'll have to do round trips across different nodes instead of one executor which could have just went to the same storage server and grabbed the information. Could also lead to skewed partitions. That's another problem. Okay, let's maybe walk through a simple example here. So let's imagine I want to scan a key range from 0 to 1,000, and I have a batch size of 200. So based on that batch size, I'm going to split it and get my partition count. Here, the partition count is derived by using a simple formula, which is the total key range size divided by the batch size. So you can see here the key ranges that we get back using the simple strategy is these ranges, R1 to R5. And since we discussed this, each subrange is mapping to Spark partition, which is working off of reading the data from the Spark, FoundationDB. Then the second one, which we use at Adobe, is the locality-based partitioner. We use the same locality util to get the boundary keys, and the boundary keys maps exactly to the number of subranges. And here, the subranges that we'll get are mapping to the input partitions. Advantages, we are using the inbuilt feature of FoundationDB, which is getting the locality info. So our reads are much more optimized, going to the right storage server, and also ensure data locality. Disadvantages, the partition size depends entirely on where the data is distributed across those nodes. So if your data distribution is uneven, we have highly skewed data, then it can become a bottleneck. Right. A simple example is, again, we'll take the same example. We are scanning the key range from A0 to 1,000. And I call the utility, I get 4 boundary keys. Using that partition count formula, I get 3 partitions here. So we saw simple partitioning, and this is locality. At least for us, this partitioner works the best based on the benchmark that we have done. Okay, I'm going to skip hybrid partitioner for now. All right, now next talk about, so we talked about how the data is distributed across these executors. Next thing is what happens when the data is distributed. Now, each of these Spark tasks is working on a specific range of data, and it's all happening in parallel. That's what makes this connector very powerful, where I'm able to retrieve, using the power of FoundationDB range queries, as well as the Spark distribution processing, I'm able to retrieve data much more fast. Right. Finally, once I have read the data, next step is transformation and collection. So once we have derived the data, Spark will collect this data and also do any shuffles that are needed. Finally, the result is aggregated. Just one thing to be aware about, this operation is very time consuming and also very expensive. So we have to be very cautious based on what configs we are setting here. Right. Now let's come to the part. How do I use this connector? So the first thing, a mandatory field like any other SQL-based connectors, we need to provide FTB source. So this FTB source resides in our own connector class. We provide subspace path. So when we are scanning the data from FoundationDB, we are providing a subspace path that we want to scan. And then we can also optionally provide the start key and end key within that subspace. This just helps us how we, and also varies how your data is organized. So it might vary based on your use case. We provide the key value, the key data type, value data type, and then the next fields are just say to FTB, how we do the connection. If TLS is enabled for your cluster, you would need to provide those certificates. The next thing is the partitioner, which we talked about. We're using locality partitioner, but this can also come in simple and hybrid. All right, so having said that, now let's talk about how are we using this connector in our workloads. So very first use case is OLAP, analytical kind of workloads, since we store wide amount of data in our database related to identity graphs. Right, the very first thing is we are running a nightly job to generate daily customer reports. We are extracting out the graph and identity counts per customer, and this information is finally used by the tenants to see how much data they're bringing in, and also for debugging and tracking purposes. Oops. And the second thing is deletion workloads. So the previous workloads we talked about where we are storing and managing our OLTP, we also have another category of deletion workloads where maybe there is some filter provided and you want to delete the data from graphs. Since deleting and scanning is an expensive operation, we merge it with this nightly job and run the deletions at one time. Then another thing is data replication to data lake. So for data replication to data lake, there are two modes. One is our incremental data processing. But let's say we don't have this customer at all available on the data lake. So the first time when we are providing or exporting the data to lake, we'll use this connector. Whatever data we get, we use data lake APIs to write to data lake, customer data lake. And then incremental updates to this data set are handled by our own custom processing, which is using Delta Lake CDC. Some operational insights. So we have deployed the Spark connector. For all our Spark-based deployments, we are using Databricks on Azure as well as AWS. This connector right now is compatible with Spark version 3.2, Scala 2.12, and Java 8. We are using self-hosted Jenkins for CI/CD deployments. The type of machines that we're using, there are a wide variety of machines that are available on Databricks. The ones that we're using is E16s, they're computer optimized, and this is just for a typical FoundationDB clusters, we use 8 machines. Some insights on if you might be wondering how much time does it take for us, for this connector to scan, given this. So one thing I'm calling out here is when we are scanning the database, we are doing it sequentially per subspace. So these are not parallelized. That's why you'll see a little bit higher amount of time, but this can always be optimized to start in multiple Spark sessions parallelly and read the data. So for us, a typical FoundationDB clusters have about 100 to 200 tenants. Total records scanned are 3 billion average. And then total time taken to scan sequentially these subspaces, it's like 5 to 6 hours. Yeah, that's our throughput, 600 megabytes per second, and typical row size is like 1 to 2 kilobytes. Right, now let's talk about the fun part, key learnings, because that's what we are here about. So when you're running this connector on production, make sure the configs that we talked about, you're carefully choosing those. So one is the partitioner configuration. If you're using simple, you have to ensure you're using the right batch size based on your data key ranges. And if you're using locality-based, how the data is distributed. Caching and persisting. So in Spark, if you have worked with it, we all know that we should always cache and persist the data frames, because calling up the Spark connector again and again might actually result in a very expensive operations, and we are creating a number of FTP clients to retrieve the data. So always cache your data frames before doing any mapping. The another learning that we had was right usage of FoundationDB APIs, because when you're retrieving the keys, there are plenty of APIs available. The key selectors that we use have to be very specific. We did encounter a major bug where we have APIs like get specific key larger than, equal, or just larger than, equal to, something like that. So when you're excluding the key ranges, you have to be very specific and make sure you use the right APIs. Another thing is based on your dataset size, you have to choose the right configuration. I just demonstrated the configuration that we use, but it might not work well or might work well for your scenario. So always benchmark whenever we are doing something like that. And another important thing was we are always capturing what is the CPU time, memory usage, and also the processing time when you're scanning the subspace. So in case any bugs are introduced, we have a way to drill down and figure out using these metrics. And one last and final call out is testing, because these are bulk operations. So just always ensure you have good unit test, integration test, and functional test to make sure it's all good. Right. In terms of roadmap and future enhancements. So today, FoundationDB already has multi-tenant mode available. We are not using that multi-tenant mode. So I guess the next thing that we could add, or we are planning to add, is support for tenant mode, RocksDB-based storage, and also bulk writes. So today, the connector that we have is doing reads. For writes, we are yet adding that support may come in coming quarters. And then the most important part, we're planning to open source this connector. So it's not there yet. It currently resides in Adobe Git, but we'll soon have a link that we can share on the FoundationDB meetup links that you can access and play around with. I think that's it. Open to question answers.
I have a question regarding the use of FoundationDB as such. So if you're using it primarily for once in a day analytics, then why do you need an ACID compliant database?
OK, just to, yeah. So we are not using FoundationDB only for OLAP workloads. This is just one of the scenarios where we need it. We have like billions of events that are coming in, which need strict ACID guarantees and also highly scalable, fault-tolerant database. That is our prime use case. So that's why we're using FoundationDB.
Thank you.
So you mentioned that a client can provide an ideal range for the sequential reads. So if the client does not, what is the ideal range and how it is decided?
So in this case, client is not providing the range. They're providing a subspace. And based on that subspace, the FoundationDB utility itself determines what is the key range. So if they do happen to provide a large key range, then the optimizations we talked about, like using the right streaming mode, the batching, limits, because a lot of times in our production scenarios, we have seen, or whoever has worked with FoundationDB can say, we'll get transaction exceeded limits or some system limits. So having that limit and batching will really help avoid those scenarios.
Got it. Thank you. And one more question that I had was, is. Okay, I think, yeah, that answers the question. Thank you.
So kind request, before asking a question, please do mention your name and the company as well.
Hi, I'm Jiu from Apple. My question is about the data you get out of FoundationDB. Since you are reading, if I remember correctly, 5 or 6 hours, that's just clarify, that's not a snapshot of the database because the data is changing.
Yeah.
So what's the...
So just to reiterate the question you're asking, is it the snapshot of the database?
Right.
Yeah. So today, when we are scanning this database, it is including for all the active tenants what subspace they belong to. We scan the entire range of that subspace. And then there are a couple of operations that need to be done after analyzing. So it is a full snapshot, but just not done. It's just done in a sequential way based on the tenants that reside in that database.
So, so the way I'm interpreting your question is, if we are doing the scan, we don't end up with a snapshot. It's loosely consistent at best. If you can stop all the mutations somehow, it becomes a snapshot. There are two ways that the team has approached this problem. One is every record that's written has a generation number, and every time we mutate that same record, we bump that up. And so the thinking is, the first sort of solution that is provided is we can work with a loosely consistent snapshot as long as there's a change log that comes along, and we can use the generation number to determine which is the most recent record. It doesn't still solve the problem of multi-record transactions. So in that scenario, the solution is the CDC itself is being written as part of the transaction. And so it's literally in some shape or form a copy of the FTB's mutation log, but written at an app level. And we are periodically taking a series of those CDCs and committing it with the Delta Lake merge into. So there is still a seeding problem, as in when you don't have anything in data lake, how do you take a snapshot out? And the best answer is don't do any mutations, run the connector. Now you have started, and then from that point forward, apply the mutations, right? So the seeding problem still exists, but the thinking in the team is with the generation numbers, we should be able to get to very close to a snapshot, a true snapshot.
Thank you, Arvind.
There is a question in online Teams chat. In what scenarios we will prefer streaming mode versus batch mode? There is another follow-up question. Why is UIS preferring, why identity preferred want all versus paginated batch responses?
Yes,
This question is from Sagar Mehra.
That's a very good question. So based on the data set size and the benchmarking we performed, it was the most optimal setting for our scenarios, and that's why we went with this. So both of them are end of the day are achieving some sort of batching, but this was just the most optimal setting for us. That's why we went with it.
Is there a use case where we would want to use the streaming mode?
So if we would want, okay, yeah, there could be some scenarios. Let's say your data set size is not as big. In that case, we could leverage streaming mode, where I don't have to worry from the client side about batching and pagination. I could simply leverage, because this is out of the box provided by FoundationDB. So I could just leverage that feature. But it does have some nuances. So I think whenever you're planning to use, there are different scenarios, like we can read it in a batch, and they'll get the next iteration in a different batch. So whichever mode we are choosing, we just have to be very careful and read the documentation thoroughly. But yeah, I think, again, try doing the benchmarks and see which works best for you. For us, this was the most optimal setting.
I think that's all the questions from the audience for now. Thank you, Akanksha, for a really great talk.
Thank you, everyone, for attending.